Before beginning this next problem, I want to point out that the method of completing the square can be used to solve all quadratic equations, whereas factoring cannot. This next problem that I'm going to show in just a moment can be solved by factoring. In fact, it would be a lot quicker. It'd be worth trying it out that way and compare, see that you get the same answers. But most or all of the other examples are going to be ones that cannot be solved by factoring, and based on what we have so far, only be solved by completing the square. Well, here we go. We're going to solve 2x squared minus 4x equals 0. And the first two steps that were just listed indicated that we had to have the terms with x on one side, which we already have, but we also need to have a 1x squared. We don't have that. We have 2x squared, so I'm going to divide both sides by 2. And for lack of a better word, that division by 2 is going to have to be distributed across the terms on the left side. We get x squared minus 2x, still equal to 0. Now, I know we have subtraction here, and there is a better way to draw this, but I and most others don't bother going through that. We split up that negative 2x, we split it up evenly, divide it by 2. That means that we'd have to have areas of minus 1x for our rectangles that we're attaching at the right and the bottom. So we've got an area of x squared here, an area of minus x, because x times negative 1, and negative 1 times x here, for a total of the x squared minus 2x that we have over here. And then we have a little square to fill in, because its quote dimensions are negative 1 by negative 1. Negative 1 times negative 1 is positive 1. We're going to add 1 to both sides. I left room over here because I want to talk about another way to write out the side work besides drawing the picture. Because of time purposes, I'm usually going to use the following. After we have the constant term on one side and we have 1x squared, we could either do this or divide the coefficient of x to the first by 2. That will give us negative 1. And we're seeing where that shows up here. Then square it. And that's going to give us a positive 1. We see where that is. In those two steps of side work, we get at the end of the second step what we need to add to the other side. But furthermore, what we have on the left side here now, oops, forgot to add the 1 to the right hand side as well. Sorry about that. So we had to add 1 to both sides. What we have on the left hand side is a perfect square trinomial. Remember that inside, if we add up those four areas, we have that total of x squared minus 2x plus 1, but also overall we've got a square that is x minus 1 by x minus 1. So its area could also be written as the quantity x minus 1 squared. So that second step of side work is showing you what we had to add to both sides. The first step is showing you what is being added or subtracted along with the x inside the quantity that is being squared. Again, we can't use this until we have the constant on one side, the x terms on the other, and that's a 1x squared. Now we can apply the square root property. It's going to cancel the square on the left, and on the right we'll have the plus minus square root of 1. Of course, the square root of 1 is 1. So we've got, when we isolate the x is equal to 1 plus or minus 1. We split that into the two cases because we're able to get rid of the square root completely. The first case with subtraction, we've got 1 minus 1 or 0 as a solution, and the second case with the addition, 1 plus 1 equaling 2 as our other solution. Again, if you go back to the beginning equation, you could have factored out a greatest common factor of 2x and come up with those two solutions a whole heck of a lot quicker.